Okay, first I'm going to apologize for the photocopy machine that's in the background. Sorry if that's making too much noise here, but I wanted to get a video recorded of section 11.2, and so 11.2 notes. As you can see in question 1, we started off with an average of $20.38. And they said the standard deviation, which we know that's the measurement of spread, is $1.51. So the first thing I did was I went $1.51 in either direction from $20.38. That gave me $21.89 and $18.87. So if the answer to this question was one standard deviation, I asked this question, does one standard deviation interval cover all the data? And you can clearly see that 1887, let's see here, we've got an $18, that goes below the lower bound, and a $22 and a $23 that go above the upper bound. So the answer to that question is no. One standard deviation is not enough. So then, not only did we go one, but we went 2 standard deviations above and 2 standard deviations down, creating a new interval that goes from $17.36 to $23.40. That was big enough to cover all the data, so the answer was 2. You're only going to have 3 choices for answers for this question, 1, 2, or 3. We won't get ridiculous and go beyond that. So, 1, 2, and 3. On the next question, as you can see, I put them all in order, and just like I will on the test. I didn't figure we needed to do the mean because you're adding up 21 different numbers and dividing by 21. I'm sure you could do that. But we did need to find the median with 21 numbers. So we took half of 21. That gave us 10.5. And as we know, based on our rule, if it ends in a half, that means you round up, and that gives you the actual place in the middle of the list, the 11th term, and so we went all the way to the 11th term, which was 82. This split the group into an upper half and a lower half. The median is not included in the upper half or the lower half. So there were 10 values below and 10 values above. So if you focus on the 10 values below and you go find the median of the 10 numbers, you'll find out that it's the average of the 5th and 6th, right? If you take half of 10, you get 5. And so then that means you're going to do the 5th and the 6th one and average them together, because there isn't one number directly in the middle. So they gave me 48.5. Then we do the same thing on the high end, same thing, 5th and 6th of the upper half, average them, get 108.5. So now we've got quartile 1, median, quartile 3, max and min were easy. So there's your 5-number summary. That's what we call the 5-number summary. Then they're going to ask me other questions, such as, what's the range? Well, the range goes from max minus min would be 171 all the way down to 32, so that would be a 139 for the range. The interquartile range, which is the Q3 minus Q1, the distance between those quartiles, is 60. On a box plot, you want to identify the 5 points. Then the 3 in the middle make the box. And the 2 on the outside get lines to go out to the edge of the box. This shows you where the concentration of data is. Oh, I showed everybody how not to make a box plot. Some kids make a box plot and they make everything look the same. And then they expect me to believe that this distance and this distance and this distance and this distance are all the same, which is not true. That's why we want to make our scale first. And I have the scale for you on the test. You just have to put the box plot on it. Okay. Here's an example on number 3. And maybe we should. That's not what I wanted. Okay, why isn't it? Okay, I don't know. Maybe that's why. So 5-number summary. Get all your values lined up. Half of 11 is 5.5. So we knew we need to round up to the 6th spot. The 6th spot is 61. That left 5 values below, 5 values above. And so we could find the middle of each group of 5. That would be our quartile 1 and 3. Do the same routine we did for the last question, range, max, minus, min. Obviously, in this case, we got an outlier at 547 and an interquartile range of 83. Come on. Trying to move this whole thing. You'll notice that the box plot looks really stacked heavily on the left side. Well, what if we ignored the outlier? What if we just flat out, what if that were my instructions? Ignore the outlier. What if we were to stop at 140? Well, then I probably would have had a box plot that looked like this. Because none of this would have been there. Because if I ignored the box or the outlier, I wouldn't have that thing going all the way out to the outside edge. It'd be much closer to my scale or the rest of my box plot. On question 4, we lined up all our data. Oops, let me get this in the right spot. So on question 4 here, on our box and whiskers plot, we've got, we put our data in order, and we found the middle, right? Half of 11 gave me 5.5, so we knew we rounded up to the 6th data value, which is 16. And then we could do the median of the bottom half and the median of the upper half. That's how we got the 13 and the 18. Once we started analyzing, what we figured out was none of the boxes were correct. None of them. I mean, first we'd start with min and max, right? This one doesn't have the correct minimum, so it's out. B, C, and D have the correct minimum. B and C have the correct maximum, but this doesn't have the correct maximum. But then when I go to something like 16, the median, which should be the center line of the box, that takes out B, and 16 should be there, and that takes out C. So we don't even have an answer choice, which is why we had to graph it ourselves. So I don't care if your scale of it is above or below, as long as I can see that you put your 5-number summary on there and then you made the box the middle 3. I just must have been just having a generic discussion with my students. So I must have just been making a generic post or generic statement about box plots. Box plots show you where 25% of the data is stored. Now, if you add up 25, 25, 25, and 25, you get 100% of the data. But each section represents 25%. So if I was talking about from here on down, that would be 75% of the data. If I was talking from here on up, that would be 50% of the data. Okay? Just because you're adding sections of 25 together. You know what? I should jump to 7 first. In this question, we looked at the range and we kind of mapped out the individual values. Looks like the ranges are about the same. And they look about the same in terms of the way they're distributed. Now, spread of the data, what's that term mean? That's another one. That's another word for range, max minus min. So it says women appear to vary about 3 years younger than men. That's true, but the two distributions are very similar in shape and spread, and that is also true. That's why letter A is correct. This is a really weird question. You see these extra dots on screen? These extra dots represent outliers. There's some that are low, some that are high. Quite a few outliers in my opinion. This company that sells frozen pizzas to different restaurants wants to know how much these restaurants are charging per slice for their pizza in different cities. I do think these box plots are a little off in terms of how they've been drawn. So when you look at these, you can see looks like this box should be moved up a little bit so that it's connecting the lines. Why the lines here are not attached to the box, I don't know. So when you look at the answers for part A here, do prices appear to be the same in the 4 markets? Well, I would say definitely no. I mean, you've got outliers, dramatic outliers, different in cities, and there just doesn't seem to be a very consistent price. Now, when you look down at letter choice D, it says no, prices appear to be both lower on average and more variable in city B. Well, definitely lower because of the outliers on the low end. More variability because from the top to the bottom, it's a bigger distance. That's what variability means. That's your spread of your data. And lastly, does the presence of any outliers affect your overall conclusion about the prices in the 4 markets? Yeah, outliers definitely tend to play a meaningful role. Oh, sorry, man. I need to stand up. Lastly is a question about 4-cylinder and 8-cylinder cars. We can see that it's going down, so the fuel efficiency is decreasing. We can see that the variability is the next thing, the variation in fuel efficiency. Well, it starts out big, and then that gets smaller, and then finally the spread is very small in the 8-cylinder cars. Just from top to bottom, that range, max minus min, is much smaller. Now, how much of the data in that last column sits underneath the 4 cylinders? Doesn't all of it sit underneath the 4 cylinders? There was no situation like this where they overlapped and you could say, oh, look, there's 25% where they overlapped. Yeah, there wasn't a situation like that. This is all below the 4 cylinders. So that's why we chose 100%. 100% or less. And I think that's it for section 11.2 notes.